Okay, we're going to talk about something we literally see every single day, but probably don't understand nearly as well as we think we do: the blue sky.
We all have that answer tucked away in our brains, right? It's one of the first things you learn in science class. But what if I told you that simple explanation is missing the biggest piece of the puzzle? What if the real reason for those deep, beautiful blues has a huge secret ingredient we never talk about?
All right, so let's start with the part of the story you probably already know. It's what we're all taught. And to be clear, it's not wrong. It's just not the whole story.
So the official term is Rayleigh scattering. The whole idea is that sunlight, which looks white to us, is actually a giant rainbow of colors all mashed together. As that light beam travels through our atmosphere and hits all the little gas molecules, it gets scattered. But, and this is the key, it doesn't scatter all the colors evenly. The best way to think about it is like this. NASA describes red light waves as being kind of long and lazy. They just cruise right through the air. But blue light? Oh, blue light waves are the total opposite. They are short, choppy, and super high energy. They're like the hyperactive kid in the class. They bump into everything and just bounce off in all directions. So when you look up at the sky, you're not seeing blue light coming in a straight line from the sun. Nope. You're seeing all that scattered blue light coming at your eyeballs from literally everywhere at once. And that's what makes the sky look blue. Seems pretty simple, right? Well, this is where it gets complicated. Because you see, if scattering was the only thing happening, sunsets would look totally different. This is the point where that simple story we all learned starts to completely fall apart. I mean, the usual explanation for a red sunset totally makes sense on its own. The sun's low, right? So its light has to travel through a ton more atmosphere to get to you. By the time that light beam reaches your eyes, pretty much all of that short, choppy blue light has been scattered away, leaving only those long, lazy red and yellow waves. But here's the paradox. This is the part that should make you go, wait a minute. If all the blue light is being scattered away to make that pretty red horizon, then why is the sky directly above your head, the zenith, not black, or at least some murky gray? Why instead is it this incredibly deep, pure, brilliant blue? Rayleigh scattering just can't explain that. So what is the secret? Well, get this. The answer was actually figured out way back in 1953 by a physicist named Edward Hurlburt. But it's only now, with our super advanced atmospheric models, that we can actually prove he was right all along. The secret ingredient, the missing piece for the sky's deepest blue, isn't down here with us. It's way, way up in the stratosphere. The answer is ozone. Yeah, that's right. The ozone layer, the very thing that protects us from nasty UV radiation, is also a master painter. See, ozone gas itself is naturally a pale blue, and when it gets super cold up in the stratosphere, that blue color actually gets deeper. It's basically acting like a giant blue filter over the entire planet. Now here's the really crucial part. Ozone doesn't scatter light. It absorbs it. It has this special property, it's called the Chapius absorption bands, that allows the ozone molecules to literally eat the yellow, orange, and red light that tries to pass through it. It just removes those colors from the light coming down from above. So you might be asking, how much of a difference does this really make? Is it a small effect? Not at all. A groundbreaking study in 2023 finally did the math. And at sunset, the amount of that deep blue color in the sky right above our heads that comes from ozone absorption is a whopping 66%. Just look at this breakdown. It's not even a close competition. 2/3 of that gorgeous pure blue we see at the zenith during sunset has nothing to do with scattering. It's from the ozone layer filtering the sunlight. Scattering is only doing about 1/3 of the work. So, what does this all mean for us? Let's finally put the whole, complete, real story together. Okay, so in the middle of the day, that light blue sky is pretty much all thanks to Rayleigh scattering. But at sunset, it becomes a team effort. The long path of light to the horizon scatters away the blue, giving us the red sunset. But for the light coming straight down from above, that's when ozone steps up, absorbs all the yellows and oranges, and leaves behind that stunning, pure blue that Rayleigh scattering could never, ever create on its own. And hey, don't just take my word for it. The scientists who wrote that 2023 paper put it pretty bluntly. The blue color of the sky cannot be solely attributed to Rayleigh scattering. It's just a way more complex and, frankly, a way cooler process than we thought. So, why is this so important? Well, because it shows us the sky isn't just blue. It's this incredible dynamic stage where physics and chemistry are constantly interacting. It's a really powerful reminder that the things we see every day, the stuff we think we have all figured out, often have these amazing invisible layers of wonder just waiting for us to find them.